Welcome. Good morning to everybody, and welcome to Trieste for those who are here and for those who are following us online. This is, I think, one of the first keynote sessions. It will be open innovation, a key driver for decarbonizing ships and shipping, and it's sponsored by Fincantieri. Well, before we start, I would like to remind Pierpaolo Ferrante, that was one of the main advocates of this very important event for the city, and he unfortunately passed away before he could see everything here happening. So I would like to recall Pierpaolo because he is not only a friend of mine, but he was one of the main architects of this event. Well, now we shall start. This session will last up to 1:30 p.m. And as I was telling before, we will discuss about open innovation and how open innovation can help in decarbonizing ships and shipping. My name is Massimo De Benedetti. I'm a Corporate Vice President for Research and Innovation at Fincantieri, who is hosting this session. And in the next one and a half hour, we will, I hope, entertain you about mainly three topics. First of all, I would like to present and introduce you who are the folks around the table. Then we will have a look to the next decade, and we will share with you how we think the cruise shipping will evolve in the next decade. And then at the end, we will discuss the role of open innovation. Well, who we are. Well, I introduced myself before. I'm Massimo De Benedetti, Vice President Fincantieri for Research and Innovation. Then we have Pierluigi Punter. Pierluigi is a Senior Vice President for Engineering and Design at the Cruise Vessel Business Unit at Fincantieri. He is an electrical engineer as a background, and he has more than 30 years of experience in shipbuilding. He covered a different leadership role, not only in the engineering department, but also in the shipyard. Then we will have Alberto Brioschi, who worked for Fincantieri Integrated System, Fincantieri S.p.A, where he is the head of engineering department. Alberto had a Master of Science in Electrotechnical Engineering at Milano Politecnico, and then he worked for different companies, and beside them, Alstom, Techint, and Building Energy. Now he's helping us in opening new opportunities in this business. Then we have Joachim Bruisman. He worked for Nedstack, where he is the head of maritime application. Joachim holds a master's degree in control system engineering and a Bachelor of Arts in industrial automation. And he also is a co-author of different articles on the application of fuel cell in different industrial verticals. Joachim worked for Boschheis, Huisman, Zestas, and is also an advisor in an expert group of the International Energy Agency. Then we have Alessandro Maccari. Alessandro worked for RINA, the Italian register, where he is director for research and development. Alessandro is a naval architect and marine engineer as a background, and he is also an advisor of the Italian administration at the International Maritime Organization since 1994. And then we have Emilio Campana. Emilio is the director of a very complex department at CNR. Emilio is a naval engineering as a background. He started working for IBM, and then he moved to the Italian CNR, the National Research Center in Italy, and where he covered different research and leadership positions. Now he is the head of this department. So this is the guys, the folks who will entertain you in this half an hour. Well, what is Fincantieri? Just a brief overview of who we are as a business. We are an Italian group with a global footprint, where a global footprint means that we can build ship virtually in every continent. We have 20 shipyards. in 4 continents. We are around 20,000 employees, and if we put together also the subcontractors, we moved around 80,000 people. We are nearly 6 billion companies revenues, and we have quite a huge backlog. We have around 33 billion as a total backlog. What does this mean? It does mean that we have work for the next 6 years, and I think that it's something quite unique in the industrial landscape in Italy. Now, how we think could be the next decade when we talk about shipbuilding? Well, first, we are considering what are the global trends that are in some way shaping our market. And if we talk about decarbonization, it's quite obvious to say that the main forces that is shaping the market is the evolving regulation. As Pierluigi and all the other colleagues will tell us before, there will be a huge effort for coming from the different lawmakers at the national, European and international level, that is the European Commission and the IMO, to reduce the environmental footprint of cruising, of shipping in general and of cruising in particular. So one of the main reasons why we are talking about decarbonization is the evolving regulation, and also an increasing request from the customers, from the ship owners, and also from the final customer to make shipping more green or greener. And we have developed 5 pillars in our research and innovation strategy, and the green ship, that is decarbonization, is one of the main important. And for each of these pillars, we have defined very challenging goals. And if we talk specifically about the green ship, we in the next decade we want to increase the ship efficiency by 30%. We want to eliminate every ship emission in ports and halve the navigation emission. We want to promote the use of reusable and recycled materials during shipbuilding, during the construction of the ship, and we will also decrease onboard and underwater acoustic emission, that is noises. And this is a picture about how decarbonization could like. Today, the state-of-the-art technology is to generate electricity on board a ship through a combination of traditional internal combustion engines and liquid natural gas. This is the state-of-the-art today. What could happen in the medium term? In the medium term, we see some sort of electrification. We think that we can use, for example, hydrogen for generating electricity on board a ship, and we think that in the long term we could have cruise ships that are completely fueled by hydrogen. Now, I would like to propose to my colleagues around the table, Pierluigi, Alberto, Alessandro, and all the others, this scheme to drive to some extent the panel. And the main question we would like to address during this session is how much is difficult to decarbonize ships, which are the most complex tasks that are ahead of us, what are the risks and which are the opportunities, and what is the right balance between incremental innovation and the radical approaches in order to cope with this difficult task? I remind all my colleagues that we have 6 minutes each for a first round of questions, so each of you will have 6 minutes to share with us your thoughts about these four main points, and then we will have another round of questions, basically more focused on open innovation, where we will have again 6 minutes each. Thank you very much. I would leave the stage to Pierluigi. Thank you.
Thank you. Good morning to everybody. I would like As a first step of these speeches, we would like to see which is the state of the art about the emission on the shipping. Okay, well, the first we would like to explain which is the emission that comes from a ship. The ships, we have a system that the engines that at internal combustion that has air, fuel, and lubricating oil. There is the main gas from the engines are oxygen, waters, carbon dioxide, nitrogen oxide, sulfur oxide, and other components. Which is the main pollutant emissions? Is the, for sure, CO2 and other GHG gases, the NOx, the SOx, the CO, the HHC, and the particulate matters. Which is among these pollutants, the pollutants that are considered in the regulations. In the regulation, there is only main three pollutants. That is the nitrogen oxide, the sulfur oxide, and the carbon dioxide. There is also the particulate takes in the regulations, but there is no limit on the particulate matter. Which is the shipping emission in the world scenario? In the world scenario, there is the shipping has a global emission of 18–30% of nitrogen oxide, about the 9% of the sulfur oxide, and the 3% on the carbon dioxide. Well, about the limit, the historical limit of the NOx emissions, this is represent the various stage that has been put on the table on the last years. We have up to 2011, the tier 1, up to 2006, the tier 2, and now for the ECA areas, there is the tier 3 limits that is coming in force in 2016. How is this can be reached? This has been reached first having the engines certificate EIPP, and also introducing the SCR as to capture the emissions. This is the status of the SOx, the sulfur oxide, where there is two diagrams, one for the global and one for the ECA area. Today, the last part for the ECA area is about the 0.1% of the sulfur in terms of fuel volume. How we can this reduce? In the last year, we installed the scrubbers that allow to reach this target. After that, there is the IDI that about the CO2 that is related to efficiency of the design index for the emission of the CO2. Up to 2013, 2015, there was the limit that was below the reference line that is related to 2009 emissions. After we passed between 2015 and 2020 on the phase 2, and we have the next target is in between 2020 and 2025 to reach a further reductions. There is also a phase 3 that is coming after 2025, but it seems that IMO is discussing in order to take before 2025 the phase 3, means to anticipate by 3 years the new rules. Okay, this is the IMO GHG strategy. You can see on the blue line, it is the expected, here's the expected emission with the actual performances of the ships that is the emission that we expect in the next years. while on the green line you have the reduction that we have to reach following the IMO strategy. As you can understand from this diagram, it is clear that we cannot limit the reduction for a single ship of 50%, that is the target. But considering that the increasing of the volume of the global emission of the CO2, we have to expect that up to 2050 we have to reduce the emission of the CO2 of the 70%. Okay, thank you.
Thank you very much, Pierluigi. You were really very timely. Thank you. Now I would like to leave the stage to Alberto Brioschi, who is the head of engineering at Fincantieri S.p.A, as I told you before. Alberto, you have 6 minutes for share with us your thoughts about decarbonization. Thank you. Alberto, we can hear you. Okay.
Are you able to hear me now?
Yes, thank you. Welcome.
Okay, I have some problem. The system is freezing. Okay.
Now we can hear you. Thank you.
Okay, perfect. Okay, before to start, I would like to spend 2 words on Fincantieri S.p.A. Fincantieri S.p.A has been established in 2015 to further widen Fincantieri Group presence both on the shipbuilding segment value chain and in other industrial segments. The mission of Fincantieri S.p.A is to supply electrical control and automation system within the marine and EV industrial segment, acting as a component integrator on Turkey basins and providing life cycle services. The headquarters is in Trieste. We have 2 engineering centers in Milan and Chioggia, and the site office in Muggiano. How Fincantieri S.p.A is involved in the decarbonizing of the ship. As a system integrator, we are involved in some refitting to integrate in the existing system propulsion of the ship, an hybrid propulsion system, installing some energy storage. Here you can find a typical scheme. There is 2 energy storage system with associated battery pack and converter units, altogether connected to the electrical network of the ship. An example on this application was Grimaldi cruise Roma and Barcelona, where the energy storage system has a battery capacity of around 5,000 kilowatt-hours and a nominal power of 3,000 kilowatts. With this configuration, considering that the installation of this kind of installation is to reduce the emission of the ship in port, we can identify the following operating mode of the ship. During the navigation, the ship is powered by the diesel generator, and the power unit of the system are charging the batteries. During the low port stay, the required power for ship is provided both from the energy storage system in parallel with the diesel generator, with the result to reduce the number of diesel generators in operation. The third one is a short port stay, where the electrical storage system are the only source for the power supply, substituting completely in the diesel generator. At the end, the UPS mode. In any situation, this system is always ready for ship blackout prevention. Another Fincantieri is also present in the ports with the cold ironing. Fincantieri has awarded for the port of Trieste cold ironing the design complete design of cold ironing of 1 megawatt for the connection of the Ro-Ro ferries. Okay, coming back on the original question, how difficult is decarbonizing the ship? Is it clear that the use of battery system can only be limited to operation of low power vessel and for short sailing distance? The use of clean alternative fuel can only be a solution to guarantee the autonomy required by the ship. In this configuration, the battery will play a role of typical network services. This means that the architecture of the ship must be redesigned to accept this type of solution. It requires space significantly greater than those required by fossil fuel system. What are the risks and which are the opportunity? We have the opportunity to improve the environmental behavior. So we believe that whether are the risks introduced by the new technology solution, we are convinced that they can be addressed and mitigated. Thank you.
Thank you very much, Alberto, for your very careful use of time. Then I would like to leave the stage to Joachim, the head of maritime application at Nedstack. Are you there, Joachim?
Yeah, I'm here.
Hi, welcome.
Thank you. So I think I have to wait a little for my share to be screened. My screen to be shared.
Fermo io.
Yes, it should be shared right now. Thank you very much.
Thank you, Joachim.
Thank you for having me on this panel. Let me quickly introduce Nedstack and our technology to everybody. Nedstack fuel cell technology is developing and making low temperature proton exchange membrane fuel cells, and we've been doing that since 1999. So we have over 20 years of experience in the research and development of fuel cells and also the application of fuel cells. And we do that from a powder to power basis. We start with bulk molding compounds. We make our own cell plates and we assemble them into stacks, which are in the end used in power systems that we design and build with co-makers from different sectors. Our focus has always been on mission critical and very high power applications. So more or less industrial application and not so much, for instance, automotive. We've been the first in the world to build a fuel cell power plant, and it's still in operation today. It's in operation for almost 10 years now. And also we were the first to build a megawatt fuel cell plant as well as a 2 megawatt plant. And what we do is we convert hydrogen, pure hydrogen, into electric power and heat. So a few of these systems are shown here. As said, in 2007, we already installed a power plant in the port of Groningen, so it's in the seaport. And the same holds for a megawatt power plant, which was in the port of Antwerp. We have maritime experience as well. This is an example of the a round trip boat in Amsterdam who sailed in 2011 with fuel cells and batteries and 80 passengers, which was approved by DNVGL at that time. And in 2016, we have built the largest and still up to now, largest PEM fuel cell power plant, which holds more than 2,000 kilowatts of power. More recently, we have been working on the second generation of maritime fuel cell systems with a 50 kilowatt unit, which has been tested on the sea conditions. And very recently, we delivered a 100 kilowatt fuel cell system. So in our opinion, if we want to continue like we do now and do everything like we are used to, decarbonizing ships might be very difficult. To start with, economic viability is of course a key driver. You need to be able as a ship owner to have a commercial business case to earn money with a decarbonized ship. And in relation to the current vessels and the current supply chain, a decarbonized solution is very expensive, both in investment as in the operational cost. However, the technology and the solutions that we need to provide decarbonized and zero emission ships are already available. We have the battery technology, we have the hydrogen technology, as well as the fuel cell technology. However, it's not been demonstrated in large volumes. So it's still new to a lot of people in shipping. Decarbonized fuels like, for instance, pure hydrogen or methanol or ammonia are not widely available yet as a fuel. And of course, if you want to go into decarbonizing seagoing vessels, you need a worldwide network of fuel availability, also of decarbonized fuels. And I think one of the key points and the most biggest challenge in decarbonizing ships is that we have to build a complete energy transition of the whole value chain in shipping. We know it's not just we replace one generator by another type, but we also have to adjust storage, we have to adjust bunkering infrastructure, ship designs maybe. So it requires a lot of people, a lot of sectors, a lot of knowledge to be transferred into a new means of propulsion of power generation. And I think in the end, we also have to accept that the vessel range that we are used to now might decrease, and maybe transport costs will have a limited increase. But then again, I think the price for that is, or the benefit of that is that we have zero emission shipping. So to make this happen, we have some complex tasks to deal with. For instance, there is not an existing supply chain. There is no fuel available in ports for decarbonized ships. It's in development, but it's not there yet. We see still a lot of debate about what would be the fuel of the future. What is the fuel you're going to store on board? Especially because hydrogen is very energy dense from a weight point of view, but from a volume point of view, and storing it on board is a very different task. We might need to accept, and that I think is also quite complex, that the standard way of working and that we are used to now might change and will need to be changed. And we have to align all stakeholders in shipping, from investments to yards, to the ship owners, to the cargo owners, and to the manufacturers of zero emission solutions. We all have to work together towards a zero emission solution. And that involves some risks, of course. Like I already mentioned, there's quite a lot of solutions out there at the moment which are looked at, and that creates a market uncertainty. Ship owners and yards don't know what path to choose. Investors are also looking, do I go to methanol or ammonia? Is it going to be fuel cells and hydrogen? And this will delay investments because we want more clarity. There's a lack of supply and demand, and it leads to a classic chicken egg problem because you don't have hydrogen in port. You don't have a ship owner wanting to sail on hydrogen because you cannot buy it. And the other way around, because there are no clients, nobody's going to invest in the infrastructure.
You have 1 minute.
Of course, if we want to implement this, new technologies need to be safe, but it also needs to be affordable because we have to decarbonize the complete fleet up to 2050, which means that we have to decarbonize a lot of vessels, which are in generally working at very low cost. And the risk is, of course, international acceptance and the availability of carbon-free fuels. It needs to be there on an international basis. Of course, there are also opportunities with this, and there's new business to be explored. there's new opportunities for making money. You could have local fuel generations, reducing a dependency on other countries. With that said, it would not be maybe the most economic solution, but it is a possibility. And of course, you would get clean and silent ships in ports, on rivers, and also at sea, improving quality of all life. If I look at the innovation...
Joachim, excuse me, your time is finishing.
Okay, sorry, I'll...
If you can drive to the conclusion, please.
Yeah, I draw to the conclusion. I think incremental innovation will help us now to implement new e-fuels, but if we want to go to zero emission, we need a more radical approach to change the whole supply chain. Thank you very much. Thank you,
Joachim. Well, now we heard we heard before the perspective of the cruise, the shipbuilders from Pierluigi, the perspective of a system integrator from Alberto, and the perspective of a component manufacturer from Joachim. Now we will have the perspective of the classification society represented by Alessandro Maccari.
Thank you. Good afternoon. I will go straight to the point with a very brief intro about RINA, which try to start. All right. Intro about RINA, which you may know as a classification society, which it is. But not only that, it's a global firm of consulting, engineering, and compliance services. You can see the map of the areas where RINA is working all around the globe. We had an impressive growth in 5 times in the last 15 years, with more than 200 offices worldwide, 8,000 ships in our class. And proud to be the first for classifying passenger ferries. The marine business currently is covering just 26–27%, and the reason for mentioning that is that the other business units, energy, transport, infrastructure, industry, and business assurance have a lot of cross-fertilization with the marine business and many important synergies. With decarbonization, we are facing a great shift, something that can be compared to the transition from sails to engines inside the ship, represented here by the pictures of Cutty Sark and the Great Eastern, moving from wind energy to the power generated inside the ship, steam, coal, and then evolving into steam turbines, the picture of Rex, Blue Ribbon, 1933, 160,000 horsepower inside, and then moving to Saturnia, Vulcania, the first diesel engines on passenger liners, saving 2/3 of the energy, and at that time considered to be the smokeless ships. Then in more recent times, 30 years ago, the cruise industry starting here with Fincantieri in Monfalcone, Crown Regal Princess, diesel electric power, which is still today the way to build cruise ships. You see that we have a variety of possible fuels around, and the ship owners and the industry is puzzled what should be next. We have a variety of opportunities. We have no silver bullet at the time being, many alternatives around, and this is confusing what could be next. If you put in the shoes of a fleet manager, it would be very difficult to forecast in which direction to turn the energy efficiency of the fleet. The crystal balls are quite foggy, obscured by clouds, and this is the reason why it's not easy going green for the whole industry. The fact is that the ship is not a standalone product, but is heavily influenced by a number of external factors. So, going back to the question posed by Massimo, yes, it is difficult, it is complex, and it is risky. Without a specific order, we have a variety of influencing factors decarbonizing the planet, availability of fuels, infrastructure, construction technology, human element, cost, regulation, and as a matter of fact, the ship is not a standalone, but a green shipping ecosystem. Also, the world is changing. We will need more energy. There will be a dramatic increase on the population and energy demand. There will be power for everybody. We are seeking for growing prosperity. And also the energy landscape is quickly transforming. If you consider that it took 40 years to have just 1 terawatt production using green energy, and now to double that, to have the second terawatt, it will take only 5 years and half the cost. It is economics and technology that are really driving this clean energy transition, not only rules and regulation. We have the example of solar power, cost decreased 73% in 10 years, onshore wind, minus 23%, and the Texas paradox that although being the first oil producer in the US, has a huge business on wind energy. So about crystal balls, foggy, not foggy, it seems that most crystal balls are tuning on a future where power is diversified and hybrid is the solution, both ashore and on board ships. About evolution or revolution of power generation, this is the picture of a Titanic, 4 funnels. The picture of energy, speed, power, the mighty power of liners. One funnel was fake, just to add on that and demonstrate how powerful the ship would be. If you could imagine a Titanic with hydrogen, the picture would be quite different. So it is not only a shift in technology, but also a change of mind. Energy, we have seen that we'll consider hydrogen as a big player. Hydrogen has the right numbers to reduce energy demand, decrease emissions, create new business and new jobs. So hydrogen is already a reality in the automotive, in the train, in the rail industry, is coming in the market with new ships, hydrogen carrier, liquid hydrogen carrier, but technology improvement in production and distribution would require a technological step forward to decrease hydrogen cost. As a matter of fact, all ship systems are affected by this transition. There is hardly any system on board or layout or arrangement which would not be impacted, so it is really a change of mind. I conclude this first part of the presentation mentioning fuel cells, because fuel cells, as we have seen, are offering quite interesting design possibilities, but consider that 1 liter of gasoline would require 3,000 more space if you use hydrogen at temperature and ambient pressure, 11 times in case of compressed hydrogen, and only, so to speak, 3.7 times more if you have hydrogen at minus 250 degrees. So it is clear that to make it a reality, we need a change across the board along the whole value chain. Thank you.
Thank you, Alessandro. These numbers were quite impressive. 3,000 times the storage capacity we need for having the same energy is quite an impressive number. I think it's one of the main difficult tasks we will have to face in the future. Thank you, Alessandro. Now I would like to leave the stage to Emilio Campana from CNR. Emilio, are you there?
Oh.
Welcome, Emilio. Thank you very much for having joined us. 6 minutes for you. Thank you. We can't hear you.
Oh, you can't?
Now you can. Now we can. Now we can't. No?
You hear me? Per niente o mi sentite basso?
Adesso ti sentiamo, Emilio. Now we can hear you.
Okay, so I'm going straight to the task.
Maybe you have some troubles with your mic.
Try to change my... Better? That better?
Okay. No.
So we are looking at solution using green hydrogen and fuel cell.
Emilio, ti sentiamo a scatti. Probabilmente è una questione di microfono. O forse se tieni il microfono delle cuffie attaccate alla bocca, non so.
Così mi senti? Ho
Sì.
tolto anche... Va meglio?
Così va meglio, grazie.
Okay. So the idea is to explore the wide use of green hydrogen cell in maritime application. The advantages of generating power via fuel cell.
Continua ad andare e venire. Man mano che tu ti allontani, ci sentiamo peggio.
Peggio. Va bene. Okay. So the advantages of generating power fuel is twofold via fuel cell, reduction of the emission and improving of the efficiency. While fuel cells are an effective alternative to conventional energy generation in shipping, combustion is much more efficient.
Non riusciamo a seguirti, Emilio.
Hydrogen provides more reliable, efficient, and clean approach compared to fossil fuel like LNG. So there are only concerns about the carbon capture and sequestration and to the transport of the hydrogen and to storage size. I want to state that in 2018, for the very first time, IMO a global agreement on targets to reduce the greenhouse gas emissions and transport. Substantial change. Now we think that fuel cell technology using hydrogen can enable shipping larger reduction, more than 90% in gas emission. There are, of course, challenges for that. Shipping fuel system need to be scaled up because most of the solution is modular now. So we must be scaled up to the decided megawatt while simultaneously addressing a number of questions: durability, compatibility with maritime conditions, new refueling facilities, problem with high volume fuel bunkering systems, so redesign complexly overall. Just a few facts is that the energy density is much more higher for hydrogen with respect to diesel. The volumetric energy, however, is lower than the diesel. The volumetric energy of the hydrogen is higher than batteries, so that makes hydrogen technology more competitive for medium and large ships. So how difficult is decarbonizing the maritime sectors? Well, there is the problem of integration of H2 and fuel cell within port operation. There are issues about developing hydrogen system, fuel cell on-board operation. There are problems with market diffusion and competitiveness, and developing also regulatory framework. So the risks are, there are relevant aspects, solving specific technical aspects, addressing the cost of hydrogen technologies. There are good opportunities for climate protection, new strategy for the market tackling and start and spurt, There are specific incremental innovation, improving hydrogen and fuel cell technology, safe storage of compressed hydrogen, environment, salty air, other problems with inclination, dynamic, shock and vibration, problem, and bunkering approach for hydrogen, and the potential scale gap for 20 megawatt. Stress that there are also breakthrough approaches needed to reduce or eliminate current density for electrolyzer, innovative polymer electrolyzer, power density and high efficient operating conditions. And then problem with the large scale production and novel solution for storage and board. Last slide. Both motor sailing pleasure boats, project which we are
Thank you, Emilio. Unfortunately, it was very difficult for us to follow your speech. I would suggest for the next round to try to change the mic or getting rid of this problem, because the slides were very interesting, but we were not able to get your words. In any case, thank you for having shared the perspective of the research part of the puzzle. Thank you very much. Now, well, if you can project, okay, thank you very much. As we were quite good at managing time, we will have a second round of questions, and then we have also some time, around 10 minutes for Q&A. So I invite the audience here. I invite the audience here and the audience online to put questions if you want. So now that we understood what are the main challenges in decarbonization, and I would like to drive your attention of something told by Joachim, that is economic viability. I think it's one of the main issues we have, because changing the paradigm in terms of fuel brings out a lot of other aspects, not only fuel cell, not only storage, but we must remember that cruise ships are made to bring around the world passengers, and so we need to keep space also for passengers, of course. Then, briefly, why do we need open innovation? But, well, basically, before around 70 to 80% of our products are delivered by suppliers. And we, as a team of research and innovation at Fincantieri, we cannot put in place innovation without the cooperation of suppliers, where with suppliers I include also the research institution and the academia and universities. So that's the basic reason why we need open innovation. We need open innovation because our products are so complex that we need a lot of players around the table, and that's the reason why we need basically open innovation. To put in place our strategies, we are building an ecosystem made by obviously Fincantieri and Cetena, that is our corporate research center. We bring at the table universities, we bring clients, we bring class societies. We join industrial fora in order to to have some tool more for putting in place open innovation, and we engage also supplier. And to some extent, this panel is a small sample of the ecosystem that we are building, because we have the shipbuilder, we have the classification society, we have the system integrator, we have the component manufacturer, and we have also research institution. And we use different tools for make open innovation happen, that are innovation challenges. We have several partnerships with research institutes and universities. We have in place a structured process of technology scouting and also of partnership with suppliers. So now, without stealing time to my fellow colleagues at the table, I would like to understand by them how open innovation can help in addressing the complex issues that we heard before, and if open innovation is preferable to a so-called closed innovation in this case. Again, please, 6 minutes each. Pierluigi, please, your thoughts.
Thank you. Okay. Waiting for the presentation. Okay. So we leave my first part of the presentation, the IMO strategy about the decarbonization and emission reductions. But now something new is coming, the Green Deal of the European Green Deal. The European Green Deal is not in force for sure, but has two very challenging targets, is to reduce the emission of 50% up in 2030 and to reach the zero emission in 2050. Where we are with which is the way that we follow in the last years about the CO2 emissions. We start in 2009 with this, as you can see on the top part of the diagram, where we have this kind of EDI index. So in 2020, we reach reductions. Now, the target of the European Green Deal force us to reach the new target in 2030, that is between 50 and 70, is depending of the intensity of the reductions, and to reach the zero in 2050. How we can reach this target of 2030? The target of 2030 could be reached by incremental development of research and to increase the efficiency of the system, but for sure not the 2050 target. Which could be the incremental approach? The incremental approach is to, as Massimo said at the beginning, could reach at maximum 20–25% of reductions. Looking the reduction of the ship speed, to have more efficient engines, to have a more efficient propulsion system and users, to increase the efficiency of the hull, and to increase the dead weight of the ships in order to have the unit emission reductions, and to supporting system like to avoid stops of the ships during the discharge of the materials, or to have a different supply in port. This, as you can see, part of this 25% of the fuel reduction has been already used to reach the target that I showed you before in the previous slide. Now it's evident to everybody that we need to move from incremental approach to radical approach. Means to change completely the ships. and as I say by my colleague, to have a logistic for the fuel, a new logistic for the fuel. As already anticipated by my colleagues, said that which is the alternative fuel is methanol, ammonia, hydrogens, and biofuel. Each of them has different problems, but in any case, for all the fuels, there is problems of viability, of the handling, of the space of storage, as said by from Macari before, technology for energy transformation, performance of the ship, and safety regulations. Here they show the characteristics of each of these alternative fuel. As you can see, there is no one fuel that you can say this is the right fuel. So as anticipated and as said by colleagues, there is no clear view which will be the fuel of the futures. For sure, there is the chain. As I said, the chain starts from the productions of the fuels up to the users, means up to the ships. For sure, the shipbuilder is concentrated mainly on the last part of the research, that in any case depending on the first part of the chain. So, what we conclude, it is clear that a close approach cannot be followed. We have to use an open approach because a so complex target, a so complex issues can be reached only with an open approach. As said by Massimo, we are, as a shipbuilder, managing a so complex product, we have is in our DNA the open approach of the innovations. So we confirm that this is what we need and this is what it is our intention to follow.
Thank you very much, Pierluigi. Now I would like to leave the stage to Alberto. Alberto, are you there?
Yes, I'm here.
Thank you.
Okay, yes, I'm here. Okay. Okay, about the open innovation, considering that we need to be present and ready from the point of view of knowledge and competitiveness for the new opportunities of the market. From our point of view, we have acted using open innovation methods. In this sense, we are working both in increasing synergies within the group and externally by undertaking collaboration with companies and universities. An example in this sense is a S.p.A project, solution for large batteries and waterborne
Riesci a sentirmi bene quando parlo?
The project is financed by the European community with the purpose to develop a full electric hybrid concept in combination with high energy battery and high power components to achieve the minimum cost per application. Another project in this that going in the same sense is the Healing European flagship action for cold ironing in the port. Also here, the aim is to develop cold and electrical ironing plants in several European community ports to assess their operational and environmental performances and changes different ships. Develop with a common European harmonized approach. Thank you.
Thank you very much, Alberto. And now it's the turn of Joachim. Joachim, what do you think the role will be of open innovation in all this complex environment?
I think open innovation is the only thing which is possible to bring this challenge to a good end. I think open innovation will help accelerate developments, because you're working on different developments and multidisciplinary developments in parallel. As a manufacturer of fuel cells, we shouldn't be telling a shipbuilder what to do. We should do that in parallel in a cooperation to share our knowledge and bring each other further to a higher level of understanding, but also maybe innovate much quicker. Of course, the knowledge and experience of different stakeholders will also help. We are all in different segments of the market. I think if you look at the cruise ships, you've been innovating them for over decades, and the same for vessels. So as a more new company to the market, we can rely on this experience and see if we can go into make bigger steps at once. So I think also the external support will improve our internal developments. And I think what is very important, that there is a synergy between complementary partners in open innovation. But there will also be some tension between competitors, especially in this new market, in these new technologies. And we're all looking for our place, and we're trying to, after maybe years of struggling and getting a product, to find also our spot in the case. So you will have some tension between projects, but I think in the end, with developing these type of systems and doing that in a faster way, we already do it on a smaller scale, and we develop our fuel cell systems together with specialists from a certain sector. And I think that sort of sums it up. Why prefer open innovation over closed is because the shipping industry itself is way too complex to work on your own. With all the different stakeholders anywhere in the supply chain, decarbonizing ships is way too complex to do it all by yourself. And the task at hand, and the technology that we have to provide to be able to decarbonize ships as of 2030 and onwards to complete decarbonization in 2050 is way too complex to do that by yourself. And only by focusing on your own products, like a storage solution or infrastructure or an energy converter, it will not be enough to propel a ship or to build a ship and have that in operation. Thank you. That was it for me.
Thank you very much, Joachim. It's very interesting, your last sentence. We do not need only a piece of technology, but we need a lot of pieces of technology, and we need to understand as an integrator how to put them together, and also how to scale up, because you mentioned some interesting application of in the megawatt order, but I think that's the real challenge will be to be able to scale up everything at that scale, and then to also again be able not only to bring at sea hydrogen and fuel cell and technologies, but also passengers. Now, Alessandro, it's your turn. What are your feelings about open innovation?
Well, I tried to make my point using the presentation. You can see here the picture that you can find in literature showing what is the concept of open innovation, that is cross-fertilization in between what you produce inside and outside of your organization, but also the consequences in terms of market exploitation, and this is probably the only way to produce a quantum leap innovation. It is also clear that solution DIY are not fit for purpose. We are not producing fragrance or fashion, so this is a global challenge. We have to play together, otherwise we will be out of the global playground. This is the reason why Rino responded creating two excellence centers. The Fuel Excellence Center and the Passenger Ships Excellence Center. On fuels, you see on the screen that we are tackling all alternatives. If you do not find anything, it will be there. And the reason for presenting this Excellence Center together with passenger ships is not only because of the key exploitation, but also because many of the tools, the technologies, and the approach that we use for passenger ships is really important in order to promote fuels and use fuels on board. So these two new excellence centers fit well together. Where, why, and who? The excellence centers are spread all over the world, so it's not something that happens in Trieste or Genoa or Hamburg or Shanghai or Miami. It is everywhere because we have a group of experts that cover with their competence what is needed, where is needed, and the smart distribution of RINA competence worldwide is the key to provide a quick answer. And the WHO is a team of communicators, technicians working on plan approval drawings, and the surveyors that look after ships. We have examples of the results of these excellence centers in terms of class compliance, having classed the first LNG fuel cruise ships using LNG not only in port but also during navigation, dual fuel ferries, assisting the first LNG bunkering. LNG is sort of a stepping stone towards decarbonization. Battery, hybrid, fuel cells, and a number of marine consultancy and advisory services for compliance at global level, at European level, across the board. So we have examples of how these excellence centers work, and these are living examples of open innovation. In terms of R&D, the RINA Marine Research and Development has an ecosystem of many different activities. On the four corners, you see that the stakeholders are ship owners, shipyards, academia, research centers, in a vast number of activities at European level, international, in Italy, with the clients, with the institutions. So this is part of the open innovation that we are pursuing and trying also to define what will be next in the research agenda, at least at the European level. So ship decarbonization is and remains a global challenge, perhaps a dream on which you have to work hard, because it's too complex to be tackled individually by individual companies. So the keywords here on the screen, you see open innovation, collaborative R&D, pre-competitive cooperation, teamwork, and industrial cross-fertilization. What is more important is that we have to remove unnecessary regulatory but also mental barriers. I would like to conclude here on a thought. I'm been used to have a quotation of Bruce Springsteen in many of my presentations because I think that it represents very well energy, power, human dynamo. In this specific case, I think that it is more appropriate for decarbonization to quote John Lennon. You may say I'm a dreamer, but I hope I will not be the only one. Frankly speaking, I don't know if John Lennon has ever been interested in ships or shipping, maybe in yellow submarines, but that's another story. Thank you.
Thank you very much, Alessandro. Well, I agree with you that we must be dreamers in order to put in place a full decarbonization of shipping. And I appreciate one of your last sentences. It is that we must remove mental and especially regulatory barrier, and we need your help here, obviously. Well, now we close this second round of questions with Emilio. Hopefully fixed his mic problems. Emilio, can you hear us?
Thank you. Do you hear me now?
Yes. Okay.
Let's hope for the best.
Thank you very much.
So, I want to start with this document, which is a European Commission document about open innovation. And talks about the most recent conception of open innovation, say 2.0. So beyond the idea that the users also has to be involved, we are focusing on this part, which is the creating of a well-functioning ecosystem that allows co-creation because this is essential for open innovation. So in this ecosystem, relevant stakeholders are collaborating along and across industry and sector-specific value chains to co-create solutions. So, and I want to share with you something that we are trying to build up at the National Research Council, my department. So we want to stress what is the role of the science in open innovation. University, higher education institution, public research and technology organization, they have a key role to play in the innovation ecosystem. As knowledge producers and also co-creators and generators of skilled human capital. So we are trying to build this ecosystem for including researchers and industries. And we call them national virtual laboratories, which are this hopefully well-functioning ecosystem. What is a national virtual laboratory? Let me show briefly what is the problem. The National Research Council is a large organization. It's the largest research organization in Italy. We have about 6,000 researchers and research engineers spread all over Italy. There is the map here, and the dots are the institutes. They are spread all over Italy in all the places. So one of the problems is that we have different research groups distributed on a national territory and in different locations, but maybe working on the same team. So we have difficulties in reaching the critical mass on decisive topics, and it's not easy to connect them to each other and to activate reciprocal form of exchange of knowledge. So to do this, we have built national research laboratories, virtual laboratories, and we have tested these virtual laboratories during the pandemic. So the idea was to launch strategic projects on strategic relevant topics and put together all the researchers that are wanted to work on this topic. They come from different institutes, they come from different disciplines, they come from different towns. They don't need to stay in the same physical lab, but they work on the same strategic project. And the good idea is, I think, that is we want to gather the skills of researchers scattered in various locations around large-scale topics and ask them to collaborate with industry. I want to show you what is one of the examples. Right? Now we are introducing this virtual lab. It's a new one. We are going to develop this lab in this fall. It's called Digital Ocean. What is the Digital Ocean concept? The idea is that we want to develop a new paradigm for marine research, marine and maritime research, which integrate and facilitate the combination use of existing technologies and tools with a new key digital technologies. So the basic idea is that to create a large, ubiquitous space of data, connections, models, simulators, tools, and digital mills, superimposed on the physical space, capable of radically innovating the research means, marine and maritime. The simultaneous use of sensor networks, underwater communication systems, satellite data, intelligent interconnection, autonomous marine vehicle, and observation networks, we put together. They are developing a large volume of data, big data. We are developing analysis and predictive analysis using artificial intelligence to solve the management of marine resources or to possibly simulate different impact on the same decision while managing the environment. So as you see, this is a strong multidisciplinary, and we need competencies spread from all over our institute. And then we want to include also industries and the relevant stakeholders. So coming to the last question about open innovation principle, we think that for the for the case of decarbonizing ship, of course, we need, for sure, we need a combination of external and internal research and development, because the combination of two can create significant value, added value, and also we can use we can make the best use of internal and external ideas. So for sure, in our understanding, decarbonizing ship, the open innovation approach is much more preferable to closed approach. As you see, I try to highlight with yellow and green, but it's easy to understand that we need a large set of different knowledge, piece of knowledge, and capabilities. So the idea is to develop an open system for this in collaboration with industry. This is what we are working on at the CM.
Thank you very much, Emilio, for having shared this new concept of virtual lab, because actually could be a very important enabler to how to say, to foster the cooperation between CNR and industrial environment. Well, talking about open innovation, I cannot remind the experience we made together some years ago when we sit at the table, share with you what were our main technological interest and main technological challenges, and we put together several projects that delivered a lot of interesting results, and I think that it was a very good example of open innovation. Well, we are arriving at the end of this session, and I would like to ask to the virtual audience if is there any question, because I do not see any question on my tablet. And then also if is there any question from the physical audience here? Okay, no question from the audience. Well, as we have well some 10 minutes, I would like to put a couple of questions myself to the colleagues. The first one is economic viability. Very, very quickly, each of you, what do you think are the main three drivers in order to put together a viable business case for shipping decarbonization? Starting from Pierluigi.
As you know, your question is not easy. Really, it's not easy.
And it's a surprise.
Yes, it is a surprise. You know that we did an exercise to understand which is the main missing informations in order to have a business case study complete. About, as I said, no, it's not easy. It's not easy. It's we have to involve. For example, we tried to do something for the hydrogen, and we are missing a lot of data that we can collect only with the open approach of the research. Mm-hmm. So we have to involve the hydrogen expert who manage the hydrogen normally in their life, mm-hmm. to understand which is the impact on a ship. Today, we are not able to evaluate which is the impact of the implementation of the hydrogens on board of the ships. Okay. This is my point of view.
So open innovation, I think it plays a key role also in understanding better the economics. Alessandro?
Well, I can give you the example of what we experience with LNG, because LNG that is now almost solved because we have ships running on LNG, probably 60% or more of the new buildings will have an LNG on board. If we have to compare this transition with the future with hydrogen, I think there are concurring factors. The first was a chicken and egg problem. I would like to have the ships, but I don't have the bunkering and infrastructure. I would like to build infrastructure, but I don't have the ship. For LNG, the matter was solved working in parallel. Infrastructure, bunkering, and ships. I think this can be also be a good example for hydrogen or any new technology. This will also very much influence the cost, the availability of the fuels, the new fuels everywhere. And then, of course, we have the regulatory barriers. It took almost 10 years to have the IGF code at the IMO dealing with LNG. We have not yet hydrogen on the horizon of the IMO, meaning that a new SOLAS with hydrogen could be drafted not before 2028, which is a major problem. And that's the reason why we have to invest in removing the regulatory barriers, in creating new rules, and bridging the gaps of technology in terms of material, containment system, tanks, and so on, that would pave the way for writing correct rules for the future.
Thank you very much, Alessandro. Alberto, what do you think are the main three drivers for a viable economic business case? We can hear you.
Okay. See, you are asking to the person that probably is in this table is the only one that has a technology well defined, because from the electrical control point of view, there is no particular problem to implement a different energy source within the ships. And I think that as was already said, probably we have to proceed step by step, and as probably has been done for renewable energy, that were help of the state in the first start of the implementation has helped to implement to develop the technology, and then I think the system can go ahead standalone quickly.
Okay, thank you. Joachim, what is your feeling?
I think first point would be for the longer term is to create an equal playing field between current fossil fuels and, for instance, the new fuels. At the moment, we see that, for instance, the cost of hydrogen to make is not that high, but because you want it, especially you like it to have it green, there's a lot of additional cost to a kilogram of hydrogen, which really outprices it when you compare it to the same amount or a similar amount of fossil fuel at the moment, especially in shipping. So creating a level playing field with fuel prices will help, of course, for the long term and for the operational costs to create a more viable solution. But if you look from the technology, which is at this point is very expensive because there's only limited applications and there's a limited demand for fuel cell systems. But if we would increase the productions and we would have the scale up of fuel cells and as well as hydrogen, prices will drop, making it more attractive. And I think the third part would be that you have funding schemes, for instance, to kickstart the market with not only saying, okay, I'm gonna fund a part of the consumption, but fund the whole value chain. And I think that's something that we see happening in Europe at the moment, that you have projects looking at both production and storage, infrastructure and consumption in one project, creating already that value and also the opportunity and solving the supply and demand problem.
Well, thank you. As integrator, we welcome your commitment in reducing fuel cell prices.
Of course.
Emilio, what are your thoughts about it?
You hear me now?
Yeah.
Yes. Okay. Well, I think that what's said by Luisma is very important, and I agree that the vision of industry from the, say, a producer of a fuel cell is like coming from the research part. I say that for us it's not. Let me say that if we want to be useful to the industrial system, and if we want to be useful to the Italian competitiveness of our industries, we have to be a couple of steps ahead. So we don't care about what is the best solution at the moment and what is the right way. We leave this completely to the industry. We try to develop new technology and try to see places in which we can have a breakthrough. Then, in the collaboration within industry, maybe we found that this technology will not be useful right now. Maybe it is useful in 5 years or in 10 years, but we need to develop the new technology as well. So we want to look at what the industries, what are the needs from the industry. We want to work with the industry on this topic, but at the same time, we have to try new ways. And I think that we have bet almost completely on the hydrogen, and we are working very hardly on this fuel cell approach. So this is our idea. Most of the technology is already available, but we want to make something really new and try to see if this goes in the interest also of large shipyards and large companies. We are trying to.
Well, thank you, Emilio. Well, now I try to briefly sum up some very quick takeaways that I'm bringing home. Well, first of all, Emilio, but also the other colleagues said that the most of technology is available. That's right, but we have a problem of scale, both in the electrical part, well, in the generation part, I'm talking about fuel cell, and we have a problem of scale also in, I think, in storage, the hydrogen. Then, so first point is the scale. Second point is the viability of the business case, and we just touched this point before. The third point is the infrastructure. So the problem mentioned lastly by Alessandro, the point is the chicken and egg. Well, I come from the automotive business, and I saw during my career there several lost occasions where the automotive manufacturer were able to deliver alternative fueled cars, like, for example, with methane, but the infrastructure were not in place. And I think that one of the basic difference between the case of the car or the ground transportation, the case of shipping, is that in the case of the car, you need a very diffused and a very large refueling infrastructure. In the case of shipping, you don't need such a wide network, and I think in that case, if the demand of new fuel will arise, I think that the infrastructure can follow. So these are the main takeaways I'm bringing home. I wish to thank all the fellow speakers at the table. I wish to thank Pierluigi, Alberto, Joachim, Alessandro, and Emilio. I wish to thank the staff from ESOF that assisted us during the panel. And finally, I wish to thank the team of Fincantieri R&I for having helped us in organizing this session. And really, I wish to thank them very much. Thank you, and I wish you a very good ESOF participation, and bye-bye.